Okay, so today we're going to be proving triangles congruent by two different theorems that we have. They're going to be side, 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 which is SSS, and then SAS, which is side, angle, side. So the first one that we have is side, side, side. Pretty easy. If we prove that all three sides of a triangle are congruent to another triangle, then that means the triangles are congruent to each other. So again, same way we started with yesterday, is we're going to start with our written given statements, then we're going to go to our picture, making sure that we're marking what's equal along the way. So again, first step right here is I have IK is equal to ME, and then MI is equal to KE. That's my given. And so again, before I go on, I'm going to go through my written given statements, which again, IK is equal to ME. Go ahead and mark it on my picture. IK and ME. And then the second written given statement, MI is equal to KE. MI is equal to KE. So I've gone through all of my written given statements, so now I just need to look at my picture. If I look at my picture, again, I'm looking for either vertical angles or reflexive property. So if I look at this between the two triangles, MIK and MEK, trying to find where the overlap's happening. And if I look, I have this side right here. So MK is in both of those triangles. So with my second step, I can say that MK is equal to MK. And again, that's going to be a reflexive property. Once I've done that, again, we can go back. I have proved that all three triangles of MIK and all three sides of MIK and all three sides of MEK are equal to each other. So again, what I'm trying to prove is this. I always want it to be my last step. So last step, I want to say triangle MIK is equal to triangle KEM. The reason that I would put it down for it is side, side, side. All three sides are equal to all three sides of the other triangle. Same thing with this next problem. Again, first thing I'm going to do is write down my given statement. JK is equal to NK, and then A is the midpoint of JN. That's my given. So again, I'm going to go through them one by one. JK and NK are equal to each other. So again, put a single line through each of those. A is the midpoint of JN. So again, second thing I'm going to say is that JA is equal to JN. Midpoint means it cuts it in half, so that means the two segments are equal of JN. So I should have said AN. Oops. So JA is equal to AN. So these two sides are equal to each other. And again, at the second step, just say definition of midpoint. I've used all my written given statements, so now I need to look at my picture. If I look at my picture between the top triangle and the bottom triangle, this side AK is in both of my triangles, so I can say AK is equal to AK. Again, that's reflexive property. So again, I've showed that all three sides, so I should go 2 and 3. All three sides of one triangle are equal to all three sides of another. So I can say triangle JAK is equal to triangle NAK by side, side, side. The second one, again, is going to be side, angle, side, so we're going to call it SAS. The biggest thing that we understand here is that when we're proving the sides, so there's going to be two sides and an angle. The angle has to be in between the two sides, just like we have in this example. So we have the angle which again, if I'm looking at this, it's in between the two sides that are equal to each other. So like where these two lines, or where these two sides touch, that's the angle that is equal. So we've got to make sure that the angles between the sides to use SAS, or side angle side. So again, with this, so flip over to the back of the notes. So again, first thing is going to be IT is equal to TE, and KT bisects angle ITE. That's my given. So again, go through IT is equal to TE. IT is equal to TE. Then with my second step, it says KT bisects angle ITE. So again, this is important. I need to make sure that I understand this is the angle that's being bisected, so I'm going to circle it. And this is an angle that is being cut in half. So if I have an angle being cut in half, I know that angles are equal to each other. And so when I look at this, this is angle ITE, this big angle here. And so the two angles that make up this big angle are going to be these two angles right here. So those are going to be the angles that are equal to each other. So with my second step, I can say that angle ITK is equal to angle ETK. By definition of an angle bisector. Again, I've looked through all my written given statements, and so now I can look at my picture. Should be able to see that a side is then common between the top and the bottom triangle. So I can say KT is equal to KT by reflexive property. So once I've got that, I've got two sides and an angle, and if I'll notice, the side or the angle right here is in between the two sides. So again, if I were looking at that, I could see it's side angle side because the angle's in between the two sides. Angles where the two sides intersect at. And so with my last step, I can say that my triangles are equal. So triangle KIT is equal to triangle KET. By, and again, two sides and an angle in between, so be SAS, side angle side. This one, same thing. E is the midpoint of CD. Again, CD is a segment, and then I know that CD bisects AB, and again, AB is a segment. By my given. So again, piece by piece, I'm going to go through this. So E is the midpoint of CD. So that means that E is the midpoint of, this is CD. And so that means that those two segments that make up CD are going to be equal to each other because E is in the middle. So I can say that ED is equal to EC. ED is equal to EC, and again, that's going to be definition of midpoint. Next thing down, CD bisects AB. So again, we just have to remember that this is what's being bisected. AB is a segment, and so that means that segment is going to be equal to a segment. So if AB is being cut in half, again, AB is this line right here, I'm going to know that the two segments that make up AB are going to be equal to each other. And so AE is equal to BE. So AE is equal to BE. Again, that's going to be definition of a segment bisector. I've used all of my written given statements, so now I can look at my picture. If I look at my picture, it looks like an hourglass. If I twisted it sideways, it would look like a bow tie. So whenever I see that, I can know that I always have vertical angles. I should have marked these with 2 lines. And so my vertical angles, I see the big X, and so I see that this angle right here is going to be this equal to this angle right here. So those are my vertical angles. So with my fourth step, I can say angle DEA is equal to angle BEC by vertical angle theorem. And so again, once I'm to this point, I can see that I have an angle and 2 sides equal, and the angle is in between the 2 sides. The angle is where the two sides intersect at. So these are my 2 sides that are equal to the other 2 sides, and where they intersect at is the angle that I have equal. And so with my last step, I can say with step 5 that triangle AED is equal to triangle BEC and again it's going to be by side angle side or SAS. With this, same thing, so this is the last one. DA is parallel to BC, E is the midpoint of AB, and then DA is equal to BC. It's my given. And so again, I'm going to go through these bit by bit. I'm going to save the parallel lines one for last because I want to make sure we understand that. So E is the midpoint of AB. So again, this is AB. E is the midpoint, so I know that the 2 segments that make up AB are going to be equal. So I'm going to be able to say that AE is equal to EB. By definition of midpoint. With my next step, let's see. So I've got DA is equal to BC, so I can mark it on my picture. AE is equal to EB, and then DA is equal to BC. And then the last thing that I have here to use is that my lines are parallel to each other. So DA is parallel to BC. And so what I'm going to do is, just like we've kind of done before, and I want you to do, is go ahead and extend those lines, the 2 parallel lines. So those are my parallel lines. And then if I looked, I could use this as my transversal. And so if these are my parallel lines, and this is my transversal, what I have here is this angle right here, angle A, and angle B, end up being both inside of my parallel lines and on different sides of the transversal, which makes them alternate interior angles. So I can say that angle DAE is equal to angle CBE. And I know that by alternate interior angles theorem. They're alternate interior angles. The lines are parallel, so that means that the alternate interior angles are equal to each other. So it's my last step. So I've proved two sides and then 1 angle. And again, the 2 sides and the angle is in between the 2 sides. The angle happens where the 2 sides are intersecting. And so I can say triangle DAE is equal to triangle CBE by SAS. It kind of bothers me that I put that last step in red, but I'm not going to change it. And so that's it. And those are the 2 theorems we learned, SSS and SAS, side, 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 and side, angle, side. Make sure that the angle is in between the 2 sides.